In Unit 10, we use SOHCAHTOA for right triangles. So for instance, in example 1, when you're looking for sine of J, sine would be opposite, so the opposite side, over the hypotenuse. So 60 over 61, and then you can divide that to get your decimal. On page 24, we need to use trig ratios for special right triangles. So if you're asked to find the sine of 30, so if you have a 30, 60, 90, which is x radical 3, 2x, and I'll draw it out. So say this is our 30, this would be x, across from the 60, x radical 3, across from the 90, 2x. Write sine of 30. Sine of 30 is equal to, because of SOHCAHTOA, opposite over hypotenuse. So opposite is x, hypotenuse is 2x. And then you would reduce this fraction. In this case, the x's cancel, and so you end up with 1/2. On page 25, example 4, find each length. So it's asking for the length of BC. BC is right here. I'm going to call it x. And this is the angle I was given. And so I have opposite and adjacent. So if I have opposite and adjacent out of SOHCAHTOA, that would be tan. So it's tan of the angle is equal to 10.2 over x. The easiest way to solve this, I think, is put this over 1 and make a proportion. So then I have 10.2 equals tan 15x. Isolate x completely before you calculate. So divide by tan 15 on both sides. And then this is what you would put in your calculator. 10.2 divided by tan 15 equals, and you should get 38.07 if we round to the nearest hundredth, and we found the length of that, so it would be BC equals this. That's our final answer. Okay, I'm on page 31 next. So from this section, the most important part is being able to solve the right triangle completely. So here we're given two sides. I know I can find the third side, the ST side, just with Pythagorean theorem, since I was given two sides of the right triangle. So I would do 5 squared plus b squared equals 5.7 squared. Solve that. And this is side measure, so nearest hundredth. So 2.74. And then now, I'll do it in a different color. I'm going to find the angle measures. So pick whichever angle you want. Say I pick T. I'm going to use the sides that were already given to me in case I made a mistake when I was solving for ST. So I'm going to use the hypotenuse. And then from angle T, we have opposite. And so that is from SOHCAHTOA. If we have opposite and hypotenuse, that's going to be sine. So it's always sine of the angle. Sine of angle T is equal to opposite 5 over hypotenuse 5.7. And angle T is already isolated, but since I'm finding a missing angle, I'm going to need inverse sine of the 5 divided by 5.7. Make sure you use divide by, not the ABC button. It wasn't working for everyone's calculator. And I'm getting 61, rounded to the whole number, 61 degrees. So that means the measure of angle T is equal to 61 degrees. And then we could just subtract from 90. We've already used 90. So we have 90 left for the angle T and angle R. So 90 minus 61 gets us 29 degrees for the measure of angle R. And so now we found ST, we found measure of angle T, and measure of angle R. On page 36, angle of elevation and depression. Remember the word problems? I just always draw out a right triangle, and whether they give me elevation or depression, I just put it here since alternate interior angles makes them congruent anyway. So it says the Seattle Space Needle casts a 67-meter shadow. Remember, shadows are on the ground. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, that's where my elevation goes. How tall is the Space Needle? So tall is asking for height. Okay, so if looking at this angle, I'm looking for the opposite and I have the adjacent. So I'm going to do tan of 70 is equal to x over 6.7. Isolate x. You can either set up a proportion or just multiply by 6.7 in this case. So tan 70, be careful of parentheses here in your calculator, times 6.7 is equal to x. So whatever we get from that, times 6.7, I'm getting 18 point, oh, I just realized it's 67, not 6.7. So going back, I was wondering why the tower is so short. So fix that, 67. 184, that's better. 184 to the nearest meter, so 184 meters. Okay, page 42, law of sines and cosines. Notice these are for non-right triangles. Non-right triangles. And so I have my two angles in one side, and so I'm going to see how many loops I have. If I'm trying to find the measure of FG, then I have the angle across from that, and then I have the side and angle here. So I have two loops. That's law of sines. So it's always sine of an angle. So I'll do sine of 39 over its opposite side, 40, is equal to sine of 32 over its opposite side, x. And then we solve this proportion. So it's going to be sine 32 times 40 equals sine 39 times x. Isolate x first, so divide by sine 39. I'm going to type all this in my calculator. And I got 33. What is it? Round lengths to the nearest tenth. 33.7. You can make sure your answer makes sense. Also, since it was across from the smaller angle, it should be less than the 40. So that should be good. Okay, now we're trying to find xz. So I'm going to call this x. And I only have one loop, one angle inside across from each other. So this is going to be law of cosine. So it's c squared equals a squared plus b squared minus 2ab cosine c. And then what was in the loop is what goes in the c values. The angle's 110. That's the cosine c. So this is going to be cosine 110. So we don't know the c squared. We can call it c squared still, or x squared. Doesn't really matter. And then the other sides are the a and b. The order of those do not matter. Okay, the biggest mistake people are making is this end part is separate. So I'm going to do my 35 squared and my 30 squared. And then that whole thing on the end is separate. So it's going to be -2 times 35 times 30 times cosine 110. And I'm getting positive 718.24. So I'm going to add all this up. Yeah, we're not doing anything yet until I finish this. So 1225 plus 90 plus 718.24 is 2033.24, and then square root that. And I'm getting that x is 45, round lengths to the nearest 10, 45.1. So it's really xz equals that. Xz equals 45.1. In this next one, we're missing the angle, so it's a little bit different. In the loop is the 7 and the angle. So the 7 is the c in this case. And then it's going to be 13 squared plus, I didn't really need those parentheses, but whatever, 11 squared minus 2 times 13 times 11 cosine c. We don't know the angle measure this time. You can change it to t if you want to, it doesn't matter. And then we fill in what we know. So 169 plus 121 minus 2 times 13 times 11 is 286 cosine c. Again, this is separate, so ignore that for a second. You can only add the 169 and 121, I mean. So 49 equals 290. Keep that separate part, 286 cosine c. We need to get the 290 away first, so we're going to subtract 290. So negative 241 is equal to negative 286 cosine c. Now I can divide by negative 286. And whatever I get from that, which I got like 0.84265, etc., I'm going to inverse cosine it because it's a missing second cosine. It's missing angle. So second cosine that, and I'm getting, rounded to the nearest degree, I'm getting 33 degrees. So the measure of angle T is 33 degrees.